Howdy folks, I'm going to take you through the procedure we use to purify our compound of interest on a small Pasteur pipette silica gel column. These are the solvents we're going to use for the column: ethyl acetate, HPLC grade, and heptane reagent grade. Weigh out 700 milligrams of silica gel. Put the silica gel into a test tube. Set up a column using a Pasteur pipette that has glass wool at the bottom with a layer of purified sand on top of that, with a little bit of solvent on top of that. The solvent is heptane and ethyl acetate, a mixture of 6 parts heptane and 4 parts ethyl acetate. Add 10 mils of the solvent mixture to the silica gel in the tube. Add the silica gel solvent mixture to the top of the Pasteur pipette and let it settle to the bottom. The clamp should be partially open, letting some solvent drip through the bottom of the Pasteur pipette. Keep adding silica gel and solvent mixture until the solvent and silica gel mixture is completely added to the column. Add purified sand to the top of the tube so that it settles onto the top of the silica gel. Next, get the sample from the refrigerator. The sample is a fermentation extract that has been dried onto silica gel. Weigh out 150 milligrams of sample. Add the sample to the top of the column. Let the sample sit in the solvent for about 15 minutes. Label test tubes 1 through 20. Tap the column to remove air bubbles from the sample. Open flow from the bottom of the column and then add solvent to the top of the column as drops start coming out of the bottom. Adjust the flow rate to a slow drip. Switch tubes out as needed. Add solvent to the top of the column as needed. The idea for this column was we were trying to separate the dark pigment from our compound, and for the most part the pigment is staying at the top of the column with just a little bit of yellow pigment coming through but staying just below it. So for the most part this appears to be working. For this column, I was actually taking the first 5 tubes at 1 mil, and after that they were 2 mil fractions. The column should continue to drip at about the same rate. Sometimes it may slow down, in which case you have to open up a little bit, but for the most part, this is the rate that the column drips for the entire time. By tube 14, the column still looks pretty much the same as it did from the beginning. After 19 tubes are collected, it's time to seal off the column, and we finished with about 40 mils of solvent having passed through the column. These are the 19 tubes that were collected from the column, and this is the column itself. So the column looks like the pigment stayed at the top with a certain amount of yellow pigment coming through, but for the most part the pigment stayed at the top. Next we're going to run a thin layer chromatogram of the 19 fractions from the column. So I spotted 5 microliters from each of the fractions onto the thin layer chromatogram, and now I'm going to put it into the developing tank. After about 15 to 20 minutes, pull the TLC plate out of the developing tank, mark the solvent front, and dry the plate. Add about 15 mils of the anisaldehyde detection agent onto the TLC plate. take the TLC plate with the detection agent on it over to the hair dryer and heat up the plate with the hair dryer, and after a few minutes, purple spots will appear in the fractions that contain the active compound. This is the final photo of the thin layer chromatogram. We combined fractions number 7, 8, 9, and 10 and evaporated the solvent from them. We were left with a dry white powder at the bottom of a 100 ml beaker, and we submitted this sample for NMR analysis. And this is a closer shot of the compound of interest after it came off the silica gel column. And here is the carbon-13 NMR spectrum that we got from that material, and the proton spectrum. So that's where the project is now. This is Mark Weber signing off from Firmalogic in Chicago.